Today we're going to talk about solving one-step equations, and we're going to talk about that we know that we use inverse operations to solve equations. So just a reminder of the inverse operations. If I'm talking about multiplication, the inverse is division. So that means if I'm multiplying, I can undo it with division, and if I'm dividing, I can undo it with multiplication. And the inverse operation for addition is subtraction. So that means I can undo addition with subtraction and undo subtraction with addition. So we're going to practice doing some problems. Okay, the first one I have is q minus 12 equals 1. The first thing I'm going to do is just draw that little line through the equal sign just to remind myself that both sides of that line are equal to each other. So no matter what I do, they have to remain equal. So I'm going to look at the side with a variable, which is this side over here. Okay, and I'm going to say what's being done to the variable. It's being subtracted by 12. So the inverse operation of subtraction is addition. So I'm going to add 12. And as soon as I write it over here, I'm going to write it over here. Okay, I'm going to add it to both sides. And then I'm going to draw that horizontal line. Now I know that minus 12 plus 12, that's 0, right? So I have q plus 0 equals, and what's 1 plus 12? 13. Now we know because of the identity property that q plus 0 is just q. So q equals 13. So now we need to talk about how do I check it? Well, we can kind of do this in our head, but we're going to solve it anyways just to show those steps. Where that q was, let's just think about it. The q was right there and it said minus 12. Well, what did we get for q? We got 13. So if I plug in 13 minus 12, that equals 1. Well, that's what we said the equation equaled. So that means we're correct. Q is worth 13. That Q is the number 13 because 13 minus 12 equals 1. Now let's do another problem. Okay, we have y plus 9 equals negative 6. So I'm going to go ahead and draw that line through the equal sign. And I look at the variable and what's being done. It's being added 9. We're adding 9 to it. So to undo that, we have to subtract 9 from both sides. Okay, so I know we've talked about the identity property. That just is going to cancel out. So I'm going to be left with y equals, and I have negative 6 and negative 9. You have to be careful. I'm adding those. That's the same as adding a negative. So negative 9 plus negative 6. I'm going to add them and keep the negative sign, and that's going to be negative 15. So to check that, I just plug that right back in, right? So I have negative 15, and I'm just drawing that box to show you where that variable was to begin with. You don't have to do that. So negative 15 plus 9, I know that if they have different signs, that I'm going to subtract and keep the sign of the bigger absolute value. So I know it's going to end up being negative, and 15 minus 9 would be 6, and that's what we said that equaled, so yes, we are correct. Okay, I have negative 9 equals negative 2n. I'm going to draw that line through the middle, and the variable's on the other side, but that's okay. What is being done to that variable? I am multiplying n times negative 2. So to solve this, I am going to undo that by using the inverse operation, which is division. Now, because that's a negative 2 being multiplied, I'm going to divide by a negative 2. Because otherwise, I'd end up with a negative n, and I want a positive n. Now, n can have a negative value, but I want a positive n that I'm solving for. So that cancels out, and I'm left with n equals negative 9 divided by negative 2. Okay, that's going to be a positive, right? So 9 divided by 2, I can come over here and solve that. 9 divided by 2, 2 goes into 9 4 times, which is 8. Subtract, I get 1. So I can say 4 1/2, or I could say 4.5. Either one would work. Okay, and I can check that by plugging it back in. Negative 2 times 4.5, and I want to see if that's 9. And yes, I can solve that. And I know a negative times a positive is a negative, right? And 2 times 5 is 10. Carry that 1. 2 times 4 is 8. Plus 1 is 9. Put my decimal, because that was one place, so that's just negative 9. Okay, we're going to do another problem. 24 equals 4c. Okay, I'm going to draw that line, and I'm going to ask myself, what's being done to the variable? Well, what is being done? The variable c, what's being done to that? It's being multiplied by 4. So to undo that, I'm going to divide by 4. If I write it there, I better write it here. Okay, so I know that 4 divided by 4 is just 1. And 1c is just equal to c because of the identity property, right? So c equals, what's 24 divided by 4? 6. So my answer is that c equals 6. How do I check that? Plug it right back in. I said 4 times c, so 4 times 6 is 24. Well, yeah, that's exactly what that said. 4 times whatever c was, which was 6, is 24. Okay, for another problem. Okay, I'm going to draw that equal sign, or the line through the equal sign, and I'm going to look, and what's being done to the variable? Well, it says in divided by 5, right? Because that means divide. So I have in divided by 5 equals 9. So since I'm dividing, to get rid of that, I use the inverse operation, which is multiplication. So I'm going to multiply by 5. Okay, so you can show that as a fraction, like 5 over 1, because that would make 5/5. Or you could just write 5. That cancels out, and I'm going to multiply this side by 5 as well. So that's going to be n equals, what's 9 times 5? 45. Plug that back in to make sure that we're correct. It said n divided by 5. Well, what did we say n was? We said it was 45. Well, what's 45 divided by 5? 9, which is exactly what that equation said. So we are correct. We solved correctly for n. N is 45. Okay, I have 11 equals m minus 4. So draw the line through the equal sign. And what's being done to the variable? It's being subtracted by 4. So to undo that, I do the inverse operation, which is addition. So I'm going to add 4 to both sides. And when I do that, minus 4 plus 4, that's just 0, which because of the identity property, I know that's just m, equals 15. So let's plug that back in and see if it's true. If I said 11 equals 15 minus 4, is that true? Is 15 minus 4 11? Yes, it is, so I'm correct. Okay, the next one we're going to do is r over 3 equals 7. Automatically, we should recognize that the fraction bar means divide, so that means r divided by 3 equals 7. So how are we going to solve this problem? If I'm dividing the variable, then I need to multiply to undo it. I use that inverse operation. So I'm going to multiply both sides by 3. You can use the dot, you can use parentheses. So I know that that will cancel out, and I'm going to be left with r equals, what's 7 times 3? 21. Now to check that, I would plug that back into the equation. It originally said r over 3 equals 7. So what did we say r was? We said r was 21. Well, is 21 divided by 3 7? Yes, it is. So as a recap, let's just remember that to solve one-step equations, we're going to use the inverse operation. So we're always going to look at the variable and ask ourselves what's being done to the variable, and we are going to do the inverse of that to solve the problem.